Assalamualaikum and hi everyone. This is the topic of IIR filter conventions for ESE 563 digital signal processing. The learning outcomes for this topic is the students should be able to describe analog digital filter transformation and mathematical relationships. The slides used in this video are based on the monograph by Dr. Hazli Hashim. IIR filter is based on infinite duration of impulse responses. There are two general approaches used to design IIR digital filters. The most common is to design an analog IIR filter and then map it into an equivalent digital filter because the art of analog filter design is highly advanced. Therefore, it is prudent to consider optimal ways for mapping these filters into the discrete time domain. Furthermore, because there are powerful design procedures that facilitate the design of analog filters, this approach to IIR filter design is relatively simple. Since there is no windowing method involved, the filter is appropriate to be designed in analog form first and later converted to digital filter. At the final phase, the design analog filter parameters are mapped into an equivalent digital filter using complex value or conformal mapping from S-plane to Z-plane through Laplace S transform into Z transform. The second approach to design IIR digital filters is to use an algorithmic design procedure, which generally requires the use of a computer to solve a set of linear and nonlinear equations. These methods may be used to design digital filters with arbitrary frequency response characteristics for which no analog filter prototype exists, or to design filters when other types of constraints are imposed on the design. In this section, we consider the approaching of mapping analog filters into digital filters. Initially, the focus will be on the design of digital low-pass filters from analog low-pass filters. Techniques for transforming these designs into more general frequency selective filters will then be discussed. Recall that Z is equal to exponent S multiplied with T, where S is equal to sigma plus j omega. And this function is actually equal to the multiplication of exponent sigma t multiplied with exponent j omega t, and in terms of Z transform, this is equal to magnitude of Z multiplied with exponent j omega, or in the polar form, it is magnitude of Z and phase of omega.